Five.
Hello, everyone. You are in room 5, and the topic here is an introduction to IoT, the Internet of Toilets. And it will be presented by Joe Karlsson. So if you have any questions, please ask them in the box next to the video or in the Slack room 5. Here we have Joe Karlsson.
Thank you so much, Manchi. Woohoo! Let's get us started. Internet of Toilets. Awesome. So first of all, let's just wet your palate a little bit here. Why does this matter? Why are you here? Why should you care? Well, did you know IoT is like exploding, and there is no end in sight in the growth of connected devices growing in the future. Now, this is a graph showing number of connected devices in the billions and projected growth for the next 5 years. I guess 4 years now. We're almost through 2020, but yeah, and honestly, like I think some of like IoT honestly is like probably the projections a little crazy, but I don't think that we're going to see a shortage of more and more connected devices growing. And as JavaScript developers, I think it's interesting looking at how we can integrate into that field. Cool. It's important, right? So the more you know, now you know why it's important. Okay, great. So my name is Joe Karlsson. I'm a software engineer and developer advocate, and I work for a little company called MongoDB. If you are at all interested in hanging out with me ever after this talk, you should totally come follow me on Twitter, Twitch, and I might be the only engineer here who has a TikTok channel, but I post quite a bit on there. We call it Tech Talk, but I post those on Twitter too if you want to follow along too. Of course, my website is just my first and last name. If you want to follow along with this talk at all, you could totally check out joekarlsson.dev/IoTKitty BF04B or scan that little QR code in the corner. Anytime I have code, resource, or anything, I'm going to be posting that QR code with that link. Go ahead and check that out. I also posted that in the Slack channel. Be sure to go check that out as well. Lastly, opinions are all my own. If I say anything crazy or wild, just know I'm not speaking for my employer. It's a personal opinion. Please don't get me fired. I love my job. Awesome. All right, cool. Oh, also, I'm a huge IoT enthusiast. Here's me standing in front of my magic mirror in my room. It's got like my calendar, currently playing on Spotify, some positive affirmations, New York Times headlines, weather, traffic estimates, etc., which is a super fun little IoT project built out with a Raspberry Pi. Also, I built this thing called Moodlight. You know, it's made with nano leaves. They're super expensive and I couldn't afford them, so I decided to build my own. I built a little server in here you can see so I can access it from the web anywhere. I'm on my iPad, but you can change all the effects on there. Each of those triangles is a 3D printed panel, and I custom wired the web server and LED circuits inside. Pretty cool, eh? Again, follow along. Scan that little QR code. Join along. Also want to say one other thing here too. This talk is, if you have any questions, feel free to post that in the QA room or on Slack. I'm going to keep an eye on both of those. I'm going to be answering them all at the end. This talk's about 45 minutes, so I'm going to leave some time for questions at the end. But if you want to hit me up on Twitter afterward, that works for me too. This talk is for people who are familiar with JavaScript, people who are interested in IoT in any language, or people who just want to see this goofy little dumb project I built and how I built it. All right, so today we're going to be talking about just a basic introduction to IoT, what it is and why it's important. I'm going to be talking about why you should be considering Node and JavaScript for your next IoT project. And then we're going to be discussing data best practices for IoT. I'm a MongoDB engineer. I'd be remiss not to talk about data management with a massive project like this. So we'll talk about a little bit. And then lastly, or not lastly, but we're going to get to my favorite part, which is digging into my actual kitty litter box and how I built it. And then lastly, I'm going to make wild speculations about the future of IoT. We can come back to this in 5 years and laugh at how wildly wrong I was about everything. Okay, cool. So what the heck is IoT? Hey, it's just the internet, but with some things on it, right? But I do want to talk, like we all know IoT, it's nests and connected devices and even your phone. Anything that has a chip in it that connects to the internet is a part of the Internet of Things. Your toaster, your refrigerator. I have light sockets in my house that are connected to the internet, right? Those are all part of the Internet of Things. But personally, my favorite part about IoT is art. I think everyone in this conference and watching this talk right now, we are uniquely positioned as engineers to explore one of the greatest artistic mediums of our generation, and that is computers, tech, and the internet. And AR, I think that it is a fascinating place to explore, and I am just wild about it. In particular, I'm obsessed with stupid shit, like putting chips in things that do not belong in. I think it is fascinating exploring the line between just stupidity and complete genius. I'm obsessed with that line. In fact, I am so obsessed with this. I started a hackathon called the Stupid Shit and Terrible Ideas That Nobody Needs Hackathon, where we built things that nobody needed. Like someone built a mobile app that only takes photos when you shake the phone, so it only takes blurry photos. Someone made a 6-foot cubed fidget cube. I'm obsessed with it. It was a fun project just to build things just because we liked it, you know? All right, so IoT, it's cool. I love it. Art's awesome. You don't have to love it, but I do. So Node and JavaScript, what the heck? Why should you be considering Node for your next IoT project? Well, did you know that over 58% of IoT developers self-identify as Node.js developers? I even got a source there. That's a source, right? That's a quorum of software engineers who develop IoT projects actually are using Node today. Whoa, interesting. I bet you didn't know that. I would argue, it's a personal opinion here, that JavaScript is a great choice for new developers. A lot of new devs coming out of boot camps are teaching themselves or learning JavaScript for development. It's an easy language to learn because you don't have to do a lot of memory management, right? There's a garbage collector built into the language. C and C++ are traditionally used for developing IoT projects, but I would argue they're harder to develop for new developers. And if you're already a JavaScript developer, why just use it, right? Like learning hardware development is already a skill. Like why have use one thing that you're comfortable with and explore this new artistic thing or this new hardware component. And then someday if you need C and C++, which there are still reasons to use those. Again, they're very small, very efficient because you have to do memory management for them. JavaScript is also very easy to update over a network. So for example, if you wanted to update your distributed IoT project built in Node and JavaScript, all you have to do is write a command that does a git pull and an npm install, and you're done, right? Traditionally, with a lower level language, you have to flash that physical piece of hardware. You have to bring it in, reflash it with the new source code, the new binary code, and send it off, right? That sucks. That's hard to update, but it's super easy to do that with JavaScript. Hey, baby, it already speaks JavaScript, right? It's already in that world, right? Let's keep using it. I don't know. This is like personal opinion, but we're already using JavaScript to speak the web. And I think it's interesting to explore that by pushing that to a new component, which is IoT and hardware. And you may have known this, but there are tons of existing libraries, APIs, and plugins for Node.js and JavaScript developers. The two biggest today are Cylon.js and Johnny 5. Those are two hello world functions written for each of them. I'm going to be going through, or I built my IoT kitty litter box using Johnny 5, which we'll be exploring that code more in depth in just a second. I would also argue JavaScript is amazing at handling event-driven apps. So, right, at its core, Node and JavaScript is callback based, and now we're like promises are sugarfied, and async is all right. But at its core, JavaScript is amazing at handling asynchronous events, click events in the browser, requests coming into a Node server, etc. But basically, some sort of event happens, we run a function in JavaScript that does something. But if you think about how IoT projects are made, you will find that this asynchronous nature matches very closely what we see with IoT architecture in the real world. So for example, let's say you're making an IoT kitty litter box and you want to wait for a cat to enter the box. What you might do, what I did, don't tell anyone, is put a internet connected scale underneath of that box and wait for a cat size object weight to be added to that box. But you're waiting for this asynchronous event to happen in the real world, and you want to run some code once that event happens. And that's what we're doing. With event-based architecture, we find that this reduced the cost of listening, because what's happening with Node, for example, it just has that single-threaded event loop. It's listening, and that's a pretty efficient cycle, right? And once an asynchronous event happens, enters the event loop, fires off, does some other code, and re-enters the event loop. That makes it really efficient to write code. And energy and time-wise, both are important for IoT. Okay, cool. So why IoT? Most devs are already using it. 58% of developers are already self-identifying as Node.js developers. JavaScript is a wonderful language for new developers to learn, and it's super easy to pick up, especially if you already know it. Why not just use it, right? Super easy to update over a network. All you have to do is an npm install or a git pull and npm install. And it already speaks JavaScript, baby. Let's just keep it going, right? It feels good. Let's just keep the party going. Tons of great libraries and frameworks. I'm using Johnny 5. I think it's great. Great place to start. JavaScript is event-driven, and it matches closely how IoT projects are made in the real world. Awesome. Did I convince anybody? I hope so. And reminder, I'm keeping an eye on the questions. Hit me up if you have any questions or comments or concerns. I'll take all those. All right, cool. So IoT data best practices. We're cruising here. So what do we do with all this data? Walk with me for a moment here. Let's say hypothetically, you make an IoT kitty litter box and you decide to start monetizing it. So you start mass producing IoT kitty litter boxes and you deploy them on the field. Let's say you have even just a small fleet, 1,000 of them, and there's 1,000 devices sending data to a single database or a single server every second, every minute, every hour. But what typically happens, like you have a moisture sensor or something right on the field. That's a lot of data coming in at all the same time, and a lot of different data considerations need to be made. IoT is unique because it's a write-heavy database application, which means that you're going to be doing more writes to your database than you're going to be doing reads. A service like Twitter or Facebook or social media, that's going to be read heavy. You have one person writing and maybe potentially millions of people reading that single instance of a database. And I think that's what we're used to as developers, but IoT requires different considerations for designing your data and schema. So what should you be looking for when you're looking for your next database when you're designing your next IoT project? I'll give you some tips here. So first of all, your database needs to ingest data quickly. Maybe not as fast as Newman ingests a chicken wing, but it needs to be able to handle like massive amounts of concurrent writes to your database from potentially thousands or millions of devices, right? Consider like Amazon Alexa. Maybe it's pinging data back to Amazon AWS servers every second. And I don't even know how many, there's probably millions and millions of those devices out in the field. That is a mass amount of writes that are happening in the database. Your database should also be event-driven, similar to your architecture, right? Based on some sort of event, you need to trigger some sort of event in your database and looking for an event-driven data structures. Flexible schemas also tend to be really great here for IoT devices. Let me give an example. So when developing this IoT kitty litter box, I added some additional sensors for the door so I could tell when it was in maintenance mode. But I was able to add that new sensor data to the updated IoT data series, no problem. And the interesting part about this too with IoT is traditionally most of the time you're doing IoT data is visualizing it on some sort of chart or graph over time. And it turns out old data actually isn't that useful, especially for my prototyping phase. It was not the big of a deal. I will say here that a common misconception about MongoDB is a schemaless database. This is actually not true. It is a flexible schema database. You can enforce schemas at a database level with MongoDB. You don't need Mongoose, but Mongoose is still dope. You can still use it. And you need to make sure it can handle time series data well. You can implement a time series data with a traditional SQL database, no problem, right? But it's much harder to do, right? Because they can be flexible and move around. And I'm going to be digging into my time series data schema that I use with MongoDB and why it's better use case than a SQL database. Okay, so I might be a little biased here. since I work for MongoDB. But MongoDB does all those things and way more. TLDR, if you're going to make an IoT project, MongoDB is the best choice for developing that IoT project. Okay, so IoT data best practices. I have to talk about, I'm a MongoDB database guy. I gotta, all right. Best practices for considering your next database on for your IT project. But your database needs to be able to ingest massive amounts of data concurrently, lots of concurrent writes to your database. You need to have a database that is event driven. You should look for a database that has a flexible schema. It is amazing for IoT. And you should be considering databases that can handle time series data sets well. Let's see here. I got a question in the comments here. So any preference for JavaScript over TS, assuming leaning one over the other isn't a barrier to entry? I have a lot of strong feelings, Keith, about TypeScript and JavaScript. I have never in my career seen a problem where type coercion has been an issue with my JavaScript or with a server architecture. I do think there's use cases for it for a large scale, but adding TypeScript to a project does add overhead. And for a small project like this, my code is honestly not that big. TypeScript would have been way overkill for this project, and I don't think it's great. There is some additional stuff you have to learn with it. Yeah, I don't know. TypeScript's okay. I'm not a huge TypeScript stan though, so there are people who have very strong feelings about it. Obviously, that's my personal opinion. It depends on the stuff. TLDR is for this project. No. Is there value to it? Sure. I think for large code bases, I think there starts to get more value for it, but you have to be aware of the overhead you're bringing in with using TypeScript. And a lot of time it's overkill. I've had people submit PRs to my open source projects that have like 200 lines of code rewriting a TypeScript, and they have to write like it makes it way more complicated, and you don't need it. I wish they'd asked me if I wanted it, because I couldn't merge the PR. Yeah, that's my 2 cents on TypeScript. Okay, great. Let's jump into something practical. I like having code in these types of presentations because it keeps it from being too abstract. But I always find that there's a fine line in these presentations with people's eyes starting to glaze over from getting too in depth with it. So this code is not going to be, we're not going to be going through every line of code in here. I am going to be showing you the important bits of it though. If you want to find more of it, I have all the source code linked in that resource I sent you, and I'll be posting those QR codes every single time source code pops up. So IoT box, this is what it actually looks like. I bought a mid-century modern box. That's my cat BMO on top of it. And yeah, it's great. You don't have to get anything fancy. I know mine is a little extra. I don't have a cool place to hide it, like a closet. So it's sitting out in the open. So I decided to get something a little nicer. But you could totally get like a $20 box on Amazon to do the same thing. And actually, here is my cat eating the circuitry before I actually had it implemented. You can see he's eating the load cells, which are basically those fancy internet-connected bathroom scales. He didn't choke on it. It wasn't powered on. At least I don't think it was. Would he get electrocuted? Maybe. He was fine, though. He didn't bite through any wires, but he was being hella naughty. Okay, so I mentioned to you I thought that this was I'm obsessed with stupid shit. I love stupid projects. And then that's when I came up with this. It was like stupid. It was literally stupid shit, right? And I thought it was dumb, but it turns out I found this review on Wirecutter for a internet-connected litter box. They gave it an 8 out of 10, and most importantly, it's selling for $500 on AutoPets. You can make some money selling this shit. I haven't monetized this. If you want to, go for it. I don't care. I'm not going to. Whatever, here's a free project for you. But as I'm telling you, like sometimes exploring things that you think are stupid can come up like a great idea can emerge from it. And I think that is so much fun. Okay, so how does my box work? Well, glad you asked, internet. So we have a connected litter box here. And when you open the box, we go into maintenance mode. Maintenance mode either means I'm cleaning litter out or I'm going to be adding litter to the box. Whatever's happening, I'm changing the base weight of the box. So when I open the box up, I have a sensor that measures when we are in maintenance mode. And that's telling the program that there's going to be a weight change that we need to watch for after we close the box. So if we close the box again, it leaves maintenance mode, and we initialize a new base weight for the box. This is the new base point. And what we do then is we wait for a cat-sized object to enter that box. Right? We're waiting for some sort of, and like my box is not smart enough to tell if it's like a possum or raccoon, but we're just waiting for something that's around 10 to 20 pounds to enter that box. We wait for a little bit for my cat to kind of stop scratching. We wait about 30 seconds. But once that happens, the cat does its business. And then we record a bathroom event. And I'm also measuring the time, and I'm passively measuring the weight of my cat. Since we have the base weight of the box, I can figure out how much weight has been added to it. So I can get a general figure of how much my cat weighs over time, every single time he uses the box. And recording that to a MongoDB database in the cloud, and then visualizing that with charts, which, by the way, MongoDB has a charts feature that's totally free. You can build in. It's amazing. But I'm doing all the data viz through there. Okay, cool. So once the cat leaves the box, we reset and reinitialize to a new base weight for that box. And we wait for a new event. Pretty cool. Anyone have any questions so far? Hit me up in the Slack channel or in the Q&A. But if you don't have any questions, let's jump into the code. So I want to go through my development process for this box from start to finish. So you can see I'm developing on a Raspberry Pi and I have it spread out to a breadboard here. But when you're developing an IoT project, the hello world of hardware is making an LED blink. You can see here I'm making this LED blink turn on and off and on using Johnny 5 and my Raspberry Pi. So let's jump in and how to do that. So when you're developing in the Johnny 5 project, obviously you have to bring it in. But the part you have to do, because Johnny 5 supports a wide variety of circuits, so we have to bring in the Raspberry Pi GPIO library. And when we initialize the new Johnny 5 board, we're just telling it, hey, Johnny 5, you're dealing with a Raspberry Pi today. Cool, pretty simple. But there's a ton of different boards. I'm using Raspberry Pi. I'd recommend using a Pi if you are new to development. I think it's a great place to start. As a full Unix environment, it's very familiar. You can set up Node from scratch. You can just SSH into it if you get stuck on something, which is how I did all my developments in Visual Studio Code, which is super great. But let's jump into the next part here. So we have our board initialized with Raspberry 5 and Johnny 5. And then we're waiting for that board to be ready to start listening to events. And once it's ready, then I'm initializing a brand new LED, and I'm telling Johnny 5 that on the 13th GPIO pin on this Raspberry Pi, I have an LED hooked up. You can find all the GPIO stands for General Purpose Input Output, and it basically is a bunch of pins on the Pi that allow you to interact with the outside world, either sending events out or receiving data back in from sensors. You can do either or. But I'm just saying on the 13th pin, I have an LED, and then there's a built-in function just saying blink. And bada bing, bada boom, you got a blinking LED, baby. All right. All right, so now we got a hello world working. Our board is initialized. Circuits are fine. I know we have a base working condition here. Let's go ahead and start developing our toilet. So we're going to do the same thing. We're just going to initialize a brand new Raspberry Pi Johnny 5 board. But the only thing different, we're going to do that instead of telling an LED to blink, we're going to initialize a magnetic switch, which I'm using to determine if that box is open or closed. And if it's an open, we're going to set maintenance mode to true, and we're going to do some things on that, like reinitialize the base weight after a certain amount of time, or close it and wait for an event. That's all it is. A switch has either an open state or a closed state. That's it. So let's see this in action. You're going to see I have a little white piece of plastic screwed to the side there. That's the magnetic switch. I'm going to be opening and closing the door, and you can see on my laptop, you can see these open and close events being registered in real time. Beep, 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 right? So now we know my box is receptive to these, or it's able to determine if my box is in maintenance mode or not. All right, cool. This part is the fun part, the load cells. The load cells are basically, those are the internet connected bathroom scales. This is how your bathroom scales work, right? You apply pressure to them and it's able to measure the weight of those. So I had actually some issues getting load cells that I purchased from Alibaba working with my project, but I had to get a little creative, but I did get it working. I actually ended up using the spawn child process built into the core Node library. And I was able to find a Python package or Python script that was able to read the script, read the load cells. At first, I set up a Python server and I set up a WebSocket connection. I was streaming that data, and it ended up getting really complicated and awful. This was so much easier and so much fun, and I loved it. So what the spawn child process does, it actually spins up another CPU process that runs this Python script, and all the data gets sent back to the Node process. And you can do that by writing out the standard input. That's the equivalent to console logging, right? Anything you console log in that Python script or print will be sent up to that Node script, which is fucking crazy cool. So I'm saying, hey, Node, I want you to spin off a Python process using this Python code, and we're going to detach that from this thread. And all the standard input from that Python script comes back up. But basically what's happening on there is every 10th of a second, that Python script is taking a weight measurement from those load cells and sending it up to my Node service, and we can do work with that. And you can handle data errors and closing events, but I didn't really need to do anything with that either. So this is actually what it looks like. I'm just going to show you what this actually looks like. All right, so we just have a while loop. It's infinitely running on this Python script. And it's just getting the weight and then printing that out. And anything that's printed gets sent up to that Node service. And it's waiting a 10th of a second and running that again. That's all it's doing. All right, let's check this out. I have the load cells loaded underneath that piece of plywood there. And you can see I'm registering the weight there every 10th of a second. It's hard to see because I couldn't get far enough away here, but I'm pressing on that board with my hand. And you can see that weight being registered in real time on my computer. So every 10th of a second, it's taking a measurement, and we're able to actually get a real-time weight measurement from that load cell using Python and spawn child process with Node. All right, time series data. So I want to show you how I'm actually structuring and saving my data here. How I'm doing this is I'm using a time series MongoDB document schema design. And why I prefer this is it's super easy to chart and graph. And again, when you're designing a schema for MongoDB, you want to design your schema based on how you're going to be using that data. And how I'm using this data is I'm charting this out. So what I'm doing is every single day I create a brand new document in my MongoDB database. I have some metadata you can see on here too. But the most important part is the events array, which you can see here. So every single time a maintenance event or a bathroom event is registered, what I'm doing is pushing a brand new event to that events array for that day. And that gets updated. And that makes it super easy because all I'm doing then is I'm charting. I just query, I pull all those events from each day and I chart that out one per day. You can see all that data, right? It's super great, super easy. And it's how we're thinking, right? This is so much easier. With a non-document based database, you're going to have really struggle with this because you're going to have you could have n number of events happening per day, but this makes it super easy to track and use that data. Pretty cool, huh? All right. Cool. This is actually me putting the whole box together. You can see that little Raspberry Pi. I'm just mounted the other side of there. I have that little plug-in for power, and that's it. That's it. It looks really ugly on the inside, I will admit, but you can't tell from the outside, right? It looks great, I think. I'm biased, but I think it gets the job done. I would love to do some better wire management maybe next time, but whatever. That's my dumb little cat sitting on top of it. I had to bribe him with lots of treats to get him to hang out on top of that box. All right, cool. So we just talked about my IoT kitty litter box here. Let's do a quick recap. So first we discussed setting up a hello world using Raspberry Pi and Johnny 5. And the hello world for IoT projects is making the LED blink. If you at home want to make an LED project or a IoT project, I recommend just buying some hardware, possibly a Raspberry Pi. Again, I think that's a great place to start. And just try to make an LED blink and just have some fun with that. Goof around with it. I think it's super fun. There's a ton of tutorials online for how to do that. Then we discussed setting up the switches and load cells for my actual IoT kitty litter box, which has been great. Then we discussed my IoT time series schema. And again, MongoDB is a great choice for any IoT project you're working on. And all right, let's go through the future of IoT. wild speculation here. You've entered the opinion zone. So in the future, we're going to see smaller and more powerful devices. This comes with a caveat, which we'll be talking about in just a moment, but we're seeing devices being able to get embedded into smaller things. Like we're seeing internet connected devices being connected to your shoes. Google's partnered and made a denim jacket that delivers notifications via a vibration in your sleeves. I've had another idea for a internet connected belt that helps with directions. So it would vibrate on your left or right side on which way you need to turn. So you don't have to have your phone out looking like an idiot or a tourist in a new city. I would love to make that someday. Okay. We're going to see JavaScript with a smaller footprint. I'm speculating we're going to see more specialized versions of JavaScript for embedded hardware. I mentioned this earlier, JavaScript has a large footprint due to its garbage collection. And we're seeing very optimized versions of JavaScript for the browser. And we're even starting to see some that are coming out for embedded hardware that are lighter weight, stripped down versions of JavaScript. And I think that is an interesting way to look at how this is going to change in the future. We'll continue to see better hardware support for JavaScript and libraries supporting hardware in JavaScript. Of course, I ran into that problem with my load cells not working correctly, but I was able to get it working. I'm speculating that'll get better in the future. So I mentioned that devices are going to get smaller and more powerful. The caveat that I wanted to call out with that one is that smaller, more powerful devices, even if they get smaller, still generate or consume the same amount of power. So, which if you've ever run a PC, you've noticed that the fan goes off, they generate a lot of heat. This is a particularly large problem for internet connected devices, especially if they don't have a dedicated power source. So your cell phone or whatever, right? Batteries are today and will continue to be the bottleneck for developing these things in the future. Lithium ion is going to get more expensive. We'll see if any of these developments get better. Apple's getting much better at using software to mitigate or to help protect the battery from being overused, which is helpful, but it's still a bottleneck for devices that we have not cracked yet. All right, let's do another big recap here of the whole project. So IoT and JS, we talked about how JavaScript is exploding and it's anything you put a chip in. I love art and stupid shit, and I love exploring it. I think that's such a great way to do it. We talked about why you should be considering Node and JavaScript for your next IoT project. I told you that 58% of JavaScript or Node developers or IoT developers already self-identify as IoT developers. I argue that JavaScript is a wonderful choice for new developers, and I'm not saying C and C++ are not good options for IoT projects. They have their place for sure. But if you're learning IoT, why not use it, IoT projects or JavaScript IoT projects are very easy to update over a network. All you have to do is a git pull and an npm install, and baby, you're done. And it already speaks JavaScript, baby. Let's keep it going. Tons of great libraries and support. Cylon.js, Johnny 5. Of course, I use Johnny 5 for my project. JavaScript is event-driven, which matches the real-world patterns of IoT projects being event-driven as well. We discussed IoT data best practices. So when you're considering your next IoT project and you need to pick a database saving that data, make sure you're picking a database that's able to ingest lots of data quickly. That means lots of concurrent writes to the database. You should look for a database that is event-driven, similar to how JavaScript and IoT projects are built. You should look for a database with a flexible schema that is very helpful for updating sensor data on IoT projects. And also, this is the one I think is most important. Make sure your database is able to handle time series data natively. That is going to make your life so much easier. I guarantee it. I promise. Okay, then we discussed my IoT kitty litter box. We first made a hello world using Johnny 5 and Raspberry Pis. If you want to get started, you should totally get started with a hello world project on your own, just to make sure everything's initialized correctly, right? And then you can go on to add additional sensors and build it out on your own. Then we discussed building out the switches and load cells on the Kitty Litter Box. And I discussed in particular how I had to use a spawn child process on that Python script in order to get that working, but it worked fine. That was super fun. Then I discussed my IoT time series schema for my litter box and using that events, right? I'm pushing new events every single time a maintenance mode or a bathroom event is detected by the box. Then lastly, I made wild speculations about the future of IoT. It's going to continue to grow, of course. We're going to see smaller, more powerful devices. I'm speculating we're going to see specialized JavaScript languages that have a smaller footprint and are better optimized for embedded devices. We're also going to continue to see better hardware support. And as they are now, and I speculate they always will be, batteries and power will be the main bottleneck for developing IoT projects. All right, almost done here. So let's say, hypothetically, I've inspired some of you to want to become an IoT and JavaScript master, or at least not even a master, maybe just play around with it. What's the best way to do it? I would say just get out there and do it, right? There's a ton of tutorials for it. Get that hello world going. But listening to me talk about a project is not going to, you're not going to learn how to do it. The best way to do something is to actually go out and make it. I think these conferences are useful for helping you figure out what is worth your time learning how to do. But you're not going to learn how to actually do something by attending conferences like this. You need to actually go out and do something based on what you've seen and learned from that conference. I get asked all the time, like, hey, Joe, how do I learn how to code? And it's like, what video series do you recommend? It's like, I don't have any. There is none. Like, that'd be like asking like an NBA player, like, hey, what YouTube videos are you watching to become a better NBA player? And they don't, right? Like, they're on the court practicing. And if you want to become a better software engineer, or you want to learn a particular language, framework, or new concept, you have to actually go out and make it, you know? Watch a Udemy course, sure, to get started and kind of figure out what the basics look like, but then go out and try to figure it out, you know? Again, if you want any of the links, resources, video recording of this talk, slides, schema, source code, all that stuff, check out that link there. If you want $100 in free Atlas credits, go to joekarlsson.dev/free Atlas credits. And Atlas is the MongoDB database as a service platform. It's amazing. You should totally go check it out. I have not set up a MongoDB cluster on my own laptop or computer for forever. I've just been hosting in the cloud. And they have a free tier that's free forever. If you ever do go over it, here's $100 though. Cool. Additional resources, source code. We have a IoT reference architecture for MongoDB projects, time series data, and best practices guide also available here. If you are interested in learning more about MongoDB, you should check out MongoDB University. That's university.mongodb.com or joekarlsson.dev/MongoDB. It's how I learned MongoDB when I got hired on as a software engineer at MongoDB, and I totally recommend it. It's totally free. It's open. There's courses for every language, all skill levels, all the way from newbie to super advanced power user. We also just launched our developer hub, which I've been writing a lot on there recently. So that's at developer.mongodb.com. You'll find tutorials, Twitch streams, blog posts, to quick start guides, whatever. We got it all covered. And if you have any questions about MongoDB, questions, comments, concerns, how to get started, I spotted a bug, how do I do this? You should check out our community forums. Again, we just launched these two. They're super cool. Go to community.mongodb.com. It's incredible. Okay, and if you want to work for MongoDB, we are always hiring. Go to joekarlsson.dev/MongoDB careers. We are hiring I think we'll be interviewing for our intern class next summer pretty soon, actually. But we're always hiring engineers, so be sure to hit me up if you want to work there. If anyone has any questions, I saw a couple come in on Slack. I'm going to be answering those. Yeah, let's see. Yes, Manchi.
Yeah, I was going to read those questions for you.
Great. Yeah, go for it.
Yeah, so we have 3 questions here. The first is, when in maintenance mode, does it record the wait changes, or does it wait till the door is closed?
Does it record the wait changes? So it records the weight of whatever is added to the box. And it doesn't wait for the box to close. So, when does it do it? Yeah, so I wait till after I close the door. Yeah, and then I wait like a minute just for everything to settle. You know what I mean? Like sometimes the litter will settle around a little bit. So I just wait like a minute, and then once it's all clear, then it sends off the new base. It records a new base weight for the box. Great question.
Okay. The second question is, how long did it take you to implement this project?
Oh, I can't remember. It's hard to say that too. It's like I feel like I'm done with it now. It's like stable and working and fine. But it took me a while, and I was kind of working it off and on for like a couple months. Probably like core work though. And this is my first like big IoT. This is my first IoT project I'd ever built. I'd say probably like 2 weeks, kind of goofing around just to get like a prototype up and running. Maybe a week. Like the board, I remember like the Hello World took me like a day to get the Raspberry Pi set up, and then I got the Hello World working. That took me like an hour or two just to like, get the circuits kind of figured out, and then add the switch, which I already had the LED working. So that was actually pretty quick. The load cells took me a while to figure out, and that was a lot of futzing. That was probably a couple days. Yeah, I don't know, a week or two off and on of work. It was like it was a side project, so I was kind of dabbling with it. But I also want to say this too, like I've been developing software for about 20 years now, like, and don't compare yourself to like if you're learning something slowly, that doesn't exist. You know what I mean? Like if you were going to do this and it took you 4 months, that's totally okay too. You know what I mean? Time doesn't really matter.
Yeah, great answer. So the last question is, why did you choose Johnny 5 over Silent? Is that because Silent are terrible shots?
Are terrible shots. Oh, Silence are terrible. Battlestar Galactica joke, which by the way, I just started rewatching that again. No, they had their hardware support wasn't what I needed. And I thought Johnny 5 was going to work with my load cells better, and ended up not being true. But also I think it has more active contributors too. Usually when I'm taking a pulse on the health of a project. I like looking at the number of issues and the number of active community members, and when it was last code was last updated on the thing. So I think that's why I chose it. It was more active. Okay, cool. If anyone has any other questions, I'm almost done here. I'm going to post again in the Slack channel a link to all the resources you can find in this deck. I'm also, if anyone has any questions, be sure to keep let's see here. Oh, Michael had a question. Where do you shop for hardware? No SparkFun and Adafruit, but you mentioned Alibaba. Any other recommendations? It depends. So Alibaba is cheaper than everything else. However, shipping it takes like 6 weeks for it to ship from Alibaba because it's shipping from China. They have a ton of hardware stuff on there, which is great. So if you're looking for cheap, you can find like the load cells are like $2. But I had to wait 6 weeks to get them. You can find everything on Amazon. Adafruit's great. It's in the US. It's much faster. Customer service incredible. It's more expensive, which sometimes I don't mind. It just depends. Like if it's a dumb project, I don't know. I'll ship it off on Alibaba, and if I'm not worried about it, I'll do it. Yeah, so I'd say my big ones: Amazon, Adafruit if I need it fast, Alibaba if I don't. It's kind of how I, mostly buy stuff. It fits. Thank you. Fun. This is supposed to be a fun presentation. I'm so glad. Yeah. Okay. Let's wrap this up here, huh? Thank you so much, everyone, for bringing me here. This was so much fun. I love it. I'm humbled to be here. This is incredible. I've never been to Salt Lake City. I can't wait to go there. I hope I get invited to be in person next year. Hope I get to meet some of you in real life instead of typing at you at a computer. But again, if you like hanging out with me at all during this presentation, you should totally come follow me on Twitter. That's the best way to get a hold of me. If you have questions about working for MongoDB, about IoT, JavaScript, Node, just programming in general, I'm your guy. If you're into TikTok, which I don't think many people are, but I do make funny videos on there. I'm not dancing, I promise. It's mostly programming memes. But yeah, let's hang out sometime. And thank you so much. I love you all so much. You're incredible. Oh, so many great things. And I'll catch you later, I guess. Manchi, do we have anything else we want to wrap it up here? It's a little early, but
it's just fine. Yeah, thank you, Joe. Thank you for the very joyful and fascinating presentation. So maybe you can drop off.
Yes, absolutely. Thanks again, everyone. I love you. Bye.
Yeah. Bye.